Welcome to another episode of Data Analytics with Python. My name remains Vincent Hope. So in today's lesson, which is our 7th recording, we're going to be dealing with frequency tables and plots. Now, let's jump right into it. Data analysis proper, using frequency tables and plots. Now let me expand this out. So one of the main goals of data analysis is to discover the relationships between variables. Very important. What are the relationships between different variables in your data sets? Frequency tables can give you an idea of these relationships by displaying the number of times or counts a variable occurs within a data set. This can be achieved using pd.crosstab function. Now let's make progress. Now the first thing to do is to load our libraries. So load libraries for data analysis. So import numpy as np, import pandas as pd, import our operating system, then we list it. So we list the directory Kaggle input Titanic. We've been using the Titanic data sets. We added it under our competitions here. Look at it, Titanic machine learning from disaster. So when we run this code here, we discover under Titanic we have train.csv, test.csv, gender.submission.csv. So now the next thing we're going to do is to load the data sets. So this is the train CSV, which is this one here we want to use. So the train CSV under Titanic input Kaggle, we're going to use the pd.read CSV and load it into Titanic train and display the data. When we run it, as we have seen before, we have this data for the first 5: passenger ID, survived, passenger class, the name, sex, age, and the rest of it. Now, let's see how we can plot or come up with a one-dimensional frequency table using Python codes. Now, what we're quickly going to do, we're going to do some coding. So first, we're going to take the cabin column. We have the cabin column here. We're going to take this cabin column under the Titanic train, convert it to string, which is text, and pass it into this character string. That's this first code, that's what it does. Moving to the second code, we use the second code. We now take the first letter, which is 0, from the cabin, for cabin, in the character cabin, which is just what we just did here. Then you pass it into the MP array and pass it into this file name, new cabin. Then we come down here, use the new cabin, pass it using the pd.categorical and pass it again into new cabin. Then to generate the first table, which is frequency table 1, we say equals to pd.crosstab index Titanic train survive. We're using this column here, the Titanic survive column, and we want to count it. So when we say frequency table 1, to get the output when we run it, so we get this output: survived 0, that's those who died is 509, 49. Those who survived is 342. So 0 died, 1 survived. Now let's move to the second code. We generate another table using the pd.crosstab. Now this one we use survive. Here we want to use class. So when we use class, we want to count it. We run to generate a frequency table. Okay. Run the frequency table. Let's see the output that comes out. Let me scroll down a bit. Run this code here. Okay, look at the output here. So under the P3 class, on class 1, we have a count of 215, class 2, 184, class 3, 491. Now let's generate another table for another class. This is P class, this is for sex. The same code, if we run the code, okay, the same thing. We have female 314, male 577. Now let's make progress. Now it says you can also use the value counts function to derive a frequency table. Now, how do we use the value counting function? This is the file titanic.train.sex value and count. This is the code. If you run this code now, now you see that male is 577, female 314. That means we can change the column here. Supposing I put the P class here, P passenger class here, and I run this code too. Okay, you can see in class 3 we have 491, class 1 we have 216, class 2 we have 184. So we are generating the frequency table or counts table for each of these columns. Now, if you want to print the frequency table sum, that's the total number, and also display the frequency table dimension or shape, when we run the code, so we have counts 891 and the type and the frequency table, which is the shape, we have 2 column 1. That means we have 2 for this one, this table here, which is table 3, we have 2 rows and 1 column, which is what is the shape that is being displayed here. Now we are done with 1-dimensional tables. Let's make progress to 2-dimensional tables. We are running 2-dimensional tables now. So for 2-dimensional tables, or 2-dimensional frequency tables, we use frequency table for PD cost tab. Now initially we used 1 column, which is what we saw here, and we said let's come up a bit here. You see 1 column here, and we said columns equals to count. But now for a 2-dimensional table, when we come down here, we use 2 columns. We use the survived, for example, and columns equals to another column, Titanic train sex, 2 columns. Then we are converting the 0 and 1 to died and survived. Then we run the frequency table and we have this output. So those who died under female are 61. Those who died under male are 488 or 68. Now, let's make progress. On the 5th frequency table, we use 2 different columns now. We said we use the same survived. Now this one is P class. Now for the frequency table 5, the columns, instead of, we change it to class 1, class 2, class 3, and we also put the died survive, and we also run this code. When we run this code down here, those are the tables. So died in class 1, those who died is 80, those who died in class 2 is 97. So you can see that we are getting a more vivid picture of the data set, what is involved. Now let's make progress. In the frequency table 6, what are we doing? Now we are still using 2 columns, survived and P class. Now, but we want to include the rows and column totals here. So we add this code margins equals to true. So which is gives you the row and column total. The same code here, and here we put an extra heading which was not here. We said rows total, then column total. When we run this code, you see that now we have this class 1, class 2, class 3, which is what we had here. But now we are adding the row total, and also the column total. So that's how it goes. Now, another way now if you want to generate a proportion table columns, now we can say the frequency table, which is this, divided by the tables dot location, which is column total, divided by this column total. That means each of this value divided by the column total, so we can know the proportion. Now you can see the slash dot frequency table lock. Then we run it. When we run it, so now you see that under this column, those who died in this portion is 0.3. Here is 0.6. Here under class 2, 0.5 for those who died. Those who survived, 0.47. Now, so this is how you run a proportion table. You can also do the same. Instead of using the slash sign, you can use frequency table dot div, frequency table row total. Here we use column total and put axis equal to 0. We run this code here. By the time we run this code here, we now have class 1, class 2. So for each row is the column, the row total, each of it is being, the proportion now is derived by dividing the table by each of the row total, by each of this row total, So here we have 0.14 for those who died under class 1 and 0.39 those who survived, and the rest continues like that. Now that is for two-dimensional array. Now if you want to get a three-dimensional frequency table, is almost the same coding with an extra column. So we have frequency table 6 equals to pd.crosstab, we have survived, we have this code here, we have p class, we also here we have sex, then margins are true. Then we say frequency table 7. When we run this code, we discover that we have survived for 1, we have the class 1, 2, 3, we also have the sex female, male. Now, if you want to make a sense of this frequency table, we can just pick a portion of it, because a frequency table point column 2, which is this one. Let's see the data that is available there. So we discover that we have 691, which is this one under 2, 691. We also have 7017, and this one. So all this one come out. Let's try for column 3 and see how it comes out. If you run this, so you see that you have 72, 300, 72, 300. So it shows you for this column. So that is a three-dimensional table. Now let's make progress. Now data analysis using plots. So we have done data analysis using frequency table. Now let's use plots. Now let's open it. Say plots or data visualizations. Another name for plots is data visualization. Are one of the easiest ways to explore and communicate relationships in data sets and gain useful insights. So many people may not be used or have the time to read frequency tables. The best way to show them the relationships or what you are trying to, the insights you are trying to gain, you use plots. Now let's go. Now for this plot, we take the code here, import numpy as np, import pandas as pd, import matplot library is the library for making plots in data analytics, then import os list directory. Now we introduced a new data set here, which is called diamonds. To get your diamonds, if we come here, you see that we have the diamond data set here. How do you get it? You just come to add inputs, go to data sets, then simply type diamonds. If you type diamonds here, you see that there are different ones that have come up, but you use this one, which is the diamonds that has a diamond black, something like a black background with a diamond here. You can see it has already been added. That's why it has this back signal. All these ones are white signals. White signals here is a black one, so it has been added. So now to show what is inside this data set, we load it. We now load this diamond. When we run this code here, we discover that we only have this CSV file, diamonds.csv. Now we're going to load this CSV file under diamonds input cargo. We're going to load it into this code, this data name here, data and diamonds data. We read it inside here. Then we said show the content. The content here, show the first 5 we have unnamed, then carat, the color here. We also have the clarity, we have the depth, we also have the carat. Okay, this is a carat. Okay, clarity. Then we have the price here. Okay, we have the cut level. So the cuts here, we have ideal, premium, good, and the rest of it. Now, so this is the data. So let's make progress and see how we're going to work with this data. Now, if you want to see the shape of this data, if you run it, you see that it has 53,349 rows and 11 columns. What are the columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But the data is 53,000 data. Now, the first thing we're going to plot is a histogram. Now, what is a histogram? In simple terms, a histogram is a type of chart or bar graph that shows the frequency distribution of data of variable in a data set. Now, how do you do that? So to plot a histogram, you use the diamond data, which is what you have where you pass the data into, .his. So the column is carat, which is the data, the column you want to plot. The figure size here, you have 6 and 9, 6 here, 9 down. Then the color green, you can change this color to any color. When you plot this, you can see now, you see the output here. Let's scroll down so we can see it clearly. Now, we can also change this now to, let's assume we change it to price. If we change this to price, we run this data set. Okay, you can see now here is price. This is the histogram for the price. So you can see that if we run it in the price, you can see, let's run the one. Okay, you can see the data set for the price. Let's take it back to carat so that we can just check, do some little explanations there. So if we say carat, so the ones with the, you can see how the carat ranges. Okay, just show that. Now let's make progress. Now you can still use the same to get a histogram, but adding more bins. So for example, we have diamond.his equals column is carat. The figure size is 8 by 8. The color is yellow. I told you can use any color. Then the bins are the categories. For example, this is a category, an interval or a collection, a group. Look at how small it is. So you have here 1, 2, 3, 4 bins, or 4 or 5 bins here. Now you want the bins to be 50. Now, and the range between 0.3.5. If you run this code here now, you can see this is the output it generates for you. Okay, this is the output it generates for you. Now let's come to box plots. What are box plots? Now a box plot, let me expand it so you can see. A box plot uses boxes and lines to show the distribution of one or more groups of numeric data. Now let's take an example. We say diamonds data dot box plot column equals to carat. When we run this code, this is the output. Now this box shows you 50, where most 50% of most of the data lie. Then here is the 25th percentile or the 25th mark. Here is the median. Now between this one here and this line here, you have all the data. Then any other one after this line is what is called outliers, which are values that are quite extreme from the normal values, which we treated in the previous lessons. Now, this is just a single box plot. You can have multiple box plots. Now, for example, you say diamond.data.box plot equals to column price. By clarity, you are plotting the price by clarity. The color is purple. You can use blue, yellow, anything. Figure size 0, 8 by 8. Now, when you run this code, which is what has been run here already, you see that it has given you H. You can see these values here. Now, if you look at this, VS1 shows that it has the highest price range. The highest price range here between VS1 and VS2. Now, the clarity, that means the more the diamond is clear, the higher the price. Now, let's make progress. Now we come to density plots. What are density plots? While a histogram shows the count of values in each range, a density plot shows the proportion or concentration of values in each range using a continuous curve. So this is also, if you want to plot a density plot, you have diamonds.data. You put the column you want to use, dot plots. Kind is density, figure 8.0, 8,8. Then X line, that means limit the X axis values between 0 and 5. Now, if we run this code, here. Okay, you have your line plots showing you how between the density of each value on the carat. So you have a higher density here, it comes down low. You have another peak here, it comes down low. Now let's make progress. So now bar graphs. Now what are bar graphs? Bar graphs uses rectangular bars to represent the distribution or count of data. Let's take an example. First, let's bring out a table so that we can do a bar graph on it. You use the carat table. We pass the diamond clarity column and pass it into the crosstab, and we get out the output here. So when we run the output, we discover that 1 here is 307.14, IF is 1,790, and so forth and so on and so forth. So if you want to get a bar graph for this is just a frequency table. So what do? You come down here, you use that carat table now, dot plot, kind is bar, then figure size 8 plus 8. When you run the code, now you discover under the carat, you can see that what? S1 here is the highest, VS2 follows suit before this. So that's how to plot a bar graph. Now, we can also have what is called a stacked bar graph. If we have a carat table, we pass a table like this, where we have clarity and color, two-dimensional table. Now, we put the code, which is what is displayed here, two-dimensional frequency table. Now, if we want to plot a graph for this, under this carat table now, we say carat.table.plot equals to bar, figure size 8, stacked true. We're trying to plot a stacked bar graph. Now, where each bar is placed on each other. Now, for D, E, F, G, where did we get D, E, F, G? Let's move up a bit. You can see D, E, F, G. These are the values here for each of them. For F, for G. Now, you come down here. You can see now for E here, then for, let's say, this purple H you here. But it will be a bit difficult to note which of these has the highest value. So the best thing to do is to use an unstacked bar graph, which is the same code here, ucarat.kindbar figure 0, but the stacked here is false. In the previous one, the stack here is true. So if you remove it, it will now come side by side. So you can know that this has the highest value here, has the highest value under VS2. The E has the highest value here, it has the highest value here. Now let's make progress. Then we have what is called scatter plots. What is a scatter plot? A scatter plot uses dots to represent values for two different numeric variables. Now let's remove this. Now how do you do that? You say diamonds underscore dot plot, kind is scatter, X is carat, Y is price, figure size is 10 by 10, X line is between 0 and 20,000. Now we run that. If we run that, so if we run this code here, we have a scatter plot. So here we have more concentration here, and as the values go up, the variables begin to scatter. So that is between the carat and the price, the carats and the price. So we have more concentration here, and the values begin to scatter. Then we now make progress. We come finally to the line plots. Now the line plots, what is the line plots? This is a graph that shows if the frequency of the number of lines or number of times a value occurs in a data using a number line. Let's remove this. Okay, so how do you proceed? So diamond.plot, we have X is clarity, Y is price, figure size is 10. You run that. When you run that, okay, you discover that here the clarity at S1 has the highest peak of what? Of price here, because we are running the values of between clarity and price. So this is how you use frequency tables and plots to do data analysis. So if